So if you'll notice, I'll just go ahead and execute the select statement running 50,000 times in one query window. We'll go to another query window and we'll execute the delete statement. And what we should see, and it's already occurred, in our select query window, whoops, darn, I ran it again. I'll have to run this one again. I hit Control E instead of Control End for some reason. So our select statement, if we go to the bottom, we notice that we do have the message transaction ID 54 was deadlocked on lock resources with another process and has been chosen as the deadlock victim. Rerun the transaction. So our end user just got, all their work blown away, and now they have to redo whatever they were doing. And then if we look at the delete statement, that finished fine. Okay, so now the most common thing that I'll see someone do in this scenario is this. I'll just add with no lock. If I add with no lock, then my select statement won't do any locking. Yeah, I'll be reading some dirty data possibly, but that should solve the problem. That is true, but you got to have an understanding of how this select statement is being used. And I've been in scenarios where there have been tables that never contained many records for any great length of time. They were just used as like temporary and processing tables, but they were high frequency inserts and deletes into that table. So adding a with no lock was not an option for us. That would have given us bad information on to the end user in the application or for whatever it was using. So this was not an option, but I do want to show that now if I run this select statement and then run the delete in another window, delete will finish and eventually the select will finish as well. And there, we've avoided our deadlock. But that's not the solution that I normally try to implement. Oh, one thing with the with, yeah, I used to be in the habit of just doing this, perfectly fine. But this is the SQL Server deprecation list under table hints category, specifying table hints without using the with keyword. That's being deprecated. The alternative now, use with. So that's something that I'm getting in the habit of doing, is just adding that with in there. So I just thought I'd mention that. All right, so let's take that out. And we'll show now, if we do this again, we're back to our deadlock scenario. Look, it already has occurred. It's been deadlocked and chosen as the deadlock victim. All right, so now how can we correct this without adding the no lock? So what we need to do is basically change our execution plan. We're getting into this situation because we're accessing a non-clustered index and the clustered index. Well, everyone that works with performance tuning knows, yeah, index seek, that's fine and everything, but anytime you have to do the key lookup, well, that's an extra step, and that's where your cost is in this operation. So why are we doing this key lookup? Let's look at our query. It's select company name where last name equals Smith and first name equals James. So our last name, first name here, that's why it's choosing the index, because it's going to be so efficient rather than trying to search through those 20,000 rows in our table. It's going to be very efficient to find the row we need, but we don't have company name. And if we weren't sure of that, we could go to the key lookup, look at the properties, look at the output list and say, hey, what's it going there for? What is the output? The output is company name. Oh, that's why it needs to go there, because it doesn't have company name on the non-clustered index. So what I'm going to do here is modify our existing index. I'm just going to drop and create. I'm going to modify our existing index to add as an included column the company name. Now, if I had 10 or 12 columns that were in that select that it was going back to the clustered index for, then yeah, I would have to add all 10 or 12 here. That's why you want to add them as included columns if you're on 2005 or later, because then they're not involved with the ordering of the index and don't need to be maintained in that way. So basically, we're just going to drop the index we have and recreate it again. Last name, first name, include company name. We'll execute that. Go ahead and close that now. And now what I want to do is see if we've changed our plan. So let's look at the estimated execution plan. And here you can see we're still doing that index seek on our non-clustered index, but then it does not need to go to the clustered index. So one, this should run faster. I mean, it might be milliseconds. We might have gone from 100 milliseconds down to 20 milliseconds or whatnot. But the fact that we do not need that additional lock on the clustered index at all should help us to alleviate the deadlock. So let's go ahead and execute the select, execute the delete. You see we're both running here. Select has not been deadlocked. The delete has finished. And then our select has finished. So that's just one method that I like to use for testing and for correcting this particular type of deadlock. As I described, there are several ways deadlocks can occur, but in the OLTP systems that I've worked with, this was the most common type of scenario. I'll see a select statement and then either the insert, update, or delete statement, one of those DML statements deadlocking with the select. All right, I hope that you found this video helpful. Thanks for watching, everyone, and have a great day.